Well, hello, everyone. Can you hear me okay? Good. So I'm going to go really long today, so you have to miss everything. No, I'm not. We're going to keep it pretty on task today. I was told to keep this one sort of simple, straightforward, so I'm going to try to do that. My name, first of all, is Jeff Semmens. I'm a senior sales engineer with InterSystems. That just means I've been here for a very long time and seen quite a few things. A lot of technologies come through. I'm pretty excited about the container stuff that we're doing now. I don't think it answers all the questions for everyone, but I think it has some really good places in there. And I want to talk a little bit more about what it means, sort of going from the last session that we just had that sort of showed the whole pipeline from pulling something in from Git and pulling it in and going through Jenkins to build a container and then using that container and then doing more development on that container. That was really interesting, and I want to sort of go through a lot of that and why that might be important to your development environments. I'm also going to have a little section at the end where I have a guest speaker who's going to speak for a little bit on an actual customer who's been doing this, and so it can give you hopefully a little more insight about what they're doing and the advantages it's given, and we'll go from there. So the guy said not to press this button because it would blank out my screen, so I thought I'd try it real quick. Really starts with I had a dream. Well, maybe other people had a dream. I don't know that I had this dream. But what if everything about my application could be replicated exactly to everyone in the development pipeline? What if every environment in which your application ran had exactly the same patches, dependencies, code base, everything about it when it is in test, production, in the developer's hands, everywhere? I mean, that to me is sort of one of the main reasons for looking at containers and going forward with containers. For developers, it's like I have to debug a system and I know the environment that I'm connecting to is going to be exactly the one that I developed it in. That's pretty cool, because how many times does a developer pass something off to test? Test says, well, it's broken. The developer says, well, it works on my machine, so it must be your problem, and vice versa. So there's all this arguing that goes on back and forth. Instead of doing that, here's a container that has everything about the application in exactly the same form that I had it when I was working on it. Huge advantages there. This next one is almost more for both sides of the fence, easily being able to check in different versions of the code and update it to all the different environments. That spoke directly to the last session that we had, which I think they're going to repeat again, which spoke to, using source control for building your components and using something like Jenkins to orchestrate how that's built and create a new container from that, which you can then pass around to all the different places that you want to. So automating that whole part of the flow is very important. And then from the system admin's point of view, I know the exact version and changes that make up my production environment. I know exactly what scripts ran to build this container and exactly what's in it. I can push a full version of that environment to wherever it needs to go. And as a plus, containers tend to be less resource intensive than full-on VMs. Plus, there's less of a system admin overhead too, because with VMs, you also have to worry about the guest OS and making sure about all of its patches and everything. So there's a nice advantage there as well. If we sort of look at different best practices for doing development, there are a number of different timelines out there or continuums or ways to do things out there. This is just one that sort of works with our technology pretty well. This isn't the only one that you could use. But it really starts with things like being able to author code. We have Atelier now. We've had Studio for a very long time. Both will still work with InterSystems Iris. They both work with Cache, Ensemble, HealthShare as well. We're not really talking about that right now. But you have a nice place to be able to author code. The next step up the ladder of, now I'm not just a developer, a sales engineer like me who never worries about source control. Now I want to go up and actually work with other people and not step on their code in their projects and ruin things as we go forward. So code control with some sort of source control comes in. Then after that, we want to be able to automate that. Make sure that we can do different things like running unit tests, whether those internal to cache or external on the application, but being able to bundle all that into the same thing. And then automating the installation. So we've been working a lot on our percent installer functionality within the product so that you can automatically build and install cache and do things that you need to, or update it. With the containers, now that we can pull a full image of InterSystems Iris or cache or Ensemble soon, the nice thing about that is that you'll be able to then just run percent installer scripts on an already installed vanilla version of these things. So you no longer have to go through that whole step of, okay, now we got to untar, got to make sure we have the right permissions, we got to make sure we have to do all of these things. I can pull this container image, I can modify it with percent installer stuff, and away I go. You then get into automating that whole cycle of coming around. That's where something like a Jenkins would come in, or some other sort of how do I build a configuration on the fly. And that the end of that can be automatically provisioning that with something like Docker. And so we're going to go through that a little bit more. So the main idea behind, or one of the main goals of all of this is really delivering consistency, right? You want to have a consistent image that you're sending out to customers. So every single time you need to be writing code, and there's well-established practices for how you write code. You then also need to be able to send that into testing and deployment. So you need to have a stable environment. You need to know what the version of the OS is, the different patches, security, all the different things about it, all the libraries, all your application code, make sure it's all imported, compiled, everything else. And every single time you go through the development process for a new version that comes out, you're going to have to go through these same cycles, right? So one of the things that containers can bring to the table is that you can help generate that consistency much easier. Mostly because you're not really worrying about OS versions much anymore. I mean, that's just part of the container that's coming down. You don't have to worry about, oh, I bring up my VM and it looks like Windows wants to do another update on it, and boy, some other library just changed and got updated. My Java virtual machine went from 7 to 8 or something like that, and oh gosh, it broke my code. With containers, you don't have to worry about that because what you are building is what we call immutable. It can't be changed. Once you have built this image of your application, that image is what the code is. We've been talking a bit more on the container tracks about being able to split your applications into real code that's running and data. Data is going to be something that you're probably going to be persisting outside of the container or used as a shared place where you can go and get those things when the container spins up. But the actual code that needs to be running, that should be a read-only type of thing. That should be immutable so that you go one place to find it, you run that. When I pass that over to test, it's the same as that code with all the different dependencies that I'm running on. And when you push it into production after it's passed the testing, you're good to go. I think I pretty much said all this stuff. I hate reading slides, so I don't think I will. This really comes down to sort of the whole continuous integration and continuous delivery pipelines that are out there. This is just one example of how people go about doing that. And you start with some developer is pushing via some sort of source control. He's pushing into, say, Git in this case. And from Git, he's then notifying the DevOps guys as like, okay, I've just put in this new version of the code. Let's go ahead and get this tested. So maybe that calls off a Jenkins script, which then builds my whole container with all the version of the application, everything I need on it. The thing about containers is that they're really sort of layers of functionality. One layer may be InterSystems Iris. Another layer may be an Apache server. Another layer may be your application code. Another layer might be some sort of Angular web application. Each of those are actually saved within the Docker image itself when you create it, when you build it, as separate pieces. So that each one of those separately, if you rebuild it, can actually go and look for the latest versions that have been approved by your development environment to be pulled into that, and that they know that they work together, which can be pretty powerful as well. Once that artifact is built, that container, or that image of the container, you can then pass that off to your testing. It's exactly what the developer has approved. because at that point it probably went back to the developer to make sure that, yes, this is exactly what I said it was. That's the same exact thing that I can push to a registry, then maybe I can pull down to production and go forward. So what have we done with containers at InterSystems? First of all, with InterSystems Iris, and probably very soon I would think Cache and Ensemble as well, we really became sort of a first citizen of the container world. How do we do that? Well, two ways really. We have a program that's called ccontainer main that has a number of parameters that allows you to externalize a lot of the system data that really shouldn't be immutable, that does need to change, like security, like your CPF file, like your journal files, things like that that change on a running system that should probably be external, except for some cases. I mean, there's always cases where you don't care and everything can be in the container itself. So that program, we author it, we support it, and it basically acts as a PID1. Docker containers themselves, when they're running on the host OS on Linux, they're running in something that's called a namespace on Linux. And so, there's normal process IDs that are on your Linux box. This gives you sort of a sandbox or what's called a namespace within that. So it starts with PID1, the first thing that's running, and then it goes on PID2, PID3, whatever else is running in that container. We've just said that when we run this container, go ahead and run this program because it's going to be PID1 and it's going to handle the cache stuff or the InterSystems Iris stuff. It will start InterSystems Iris or cache. It will also bring it down correctly. So if you notice when I start one of these things, it starts very quickly. It's just up, it's running, I'm ready to use it. When I bring it down, you see a bit of a pause because it's going through all the work to correctly bring down our product, which can be pretty important. More good practices that we're talking about is really the ability to, keep the data that does change external to the container, and the data or the code that doesn't change, or maybe the main data that is non-changeable stays in the container itself. That's something that you look at into your application-wide settings and take a look at yourself to figure out what's the best practices in that scope. We have a few ideas for you. So definitely come to us and ask, especially as sales engineers. We're usually more than glad to, if we don't know the answer, we tend to know the people in the organization who do know the answers, which can work out pretty well. I talked a little bit about how we're externalizing some of this. The new feature that's going to be in InterSystems Iris that isn't in anything before this is called, the project was called Durable %sys. So basically the ability to take all this system information like security and CPF and log files and everything else and be able to tell Docker that I'm going to host these external to it in some sort of directory on the host OS. There are a lot more things that we can talk about on that. But really some of the main ones is being able to put this is just a standard Docker volume command that says I want to have an external directory associated with this internal directory. So it's like a mapping straight between them. And then we have a new parameter that's like -e that basically says I have an ISC data directory and I want all of my configuration information to live, say, in this directory here. Now I just want to demo a little bit. This is pretty quick because it's hopefully a pretty straightforward concept of what we're going through. So first, let me say that I'm going to be demoing something that I'm pulling down from just GitHub. We have a repository which is now public to you guys, so you can download it. This exact same code, everything. I actually just downloaded a container that had all this already built for me. So I took it one step further. It's sort of like I'm in the test group, and Jenkins has just run, and it's built my whole container for me. The session right before this, you could actually see the whole thing where they actually built it with Jenkins and started using it and everything else. To me, I'm taking it as an artifact they've built for me already, and all I'm doing is pulling an image of it, and then I'm going to send it through my tests and things that I need to do externally. wherever they are. One of the things I want you to look at, though, so on the website itself, we have a Docker file, we have a Jenkins file, we have a number of things that allow you to build this successfully and to use our percent installer. And if we just take a look at the Docker file real quick, other Docker files that I've shown at the conference have been very, very simple. I mean, I basically pulled our thing, copied a key into it, and then said, okay, this is great. This is actually a much fuller example of a Docker file that you might use with one of our images. I mean, the first line, let's see. Do you guys know the command to make it bigger on the, what's that? Command plus, thank you. Command plus. Oh, thank you. You're my hero. So if we take a look at this really quickly, the first thing it says is just this is our internal Docker repository, if you will. Eventually this is going to be probably the second one where we're going to have a public repository that's actually official from us. That's like InterSystems, InterSystems Iris, or I'm not sure what the naming convention is going to be. In this case, it says go ahead and pull that down. So it's going to say create an image using this as a base image. I have a label, so as you can see, I didn't create this, Sylvain did. And then a number of arguments, like my package user password, a number of arguments and environment variables that I might want to set up while doing this. These are all just Docker commands for the most part. What the app name is, what working directory I'm going to use. I want to copy everything into my app directory from my temp install directory. I want to copy a key if it's present. A number of different things here as we go down. And then I'd want to run a number of commands. This is where it starts to get interesting because this is where it starts to take advantage of our percent installer functionality and things like that, where it allows you to create an install script. It loads and compiles all the classes necessary into the running version of InterSystems Iris that was downloaded. It then runs a build method for everything. So now that it's loaded all the classes, it builds everything correctly as the application has been designed. It then does some population of data in here. It then sets up CSP applications for different classes for both the REST interface for this application and also the Angular front end for this application. And by the way, this application has a great series of articles on it on the developer community by one of our sales engineers for TrackCare based out of the UK. I think it's about a 13-part series where he takes you from almost nothing in the application to a full-on AngularJS application running against a RESTful backend on a cache system. And again, we put this all up on GitHub so you can take a look at it and play with it. We then come down through here and we're writing some stuff. We are doing the install script. We are setting up logs. We are then doing C-control start of the instance name, a C session into it, C-control stop, copying a few other application stuff, and then saying which ports to expose externally for this application to run. And the main entry point. So one of the biggest things in here is that the main entry point for this is going to be our C container main program that we install in there. So let's see what that looks like. I have this thing. It's already been built for me. So this Docker file has been built completely. I'm now going to go into my terminal here, and I am going to go to my notes because I don't like typing in long things because my typing has gotten worse over the years. Let's copy that, paste it in. This basically says, okay, I want to run an image that I already have. I'll list the images in a second so you can see, yes, it was really there. And I want to do it, I want to have different ports available. So I have port 59001 on the host OS, and internally it's 57772, just the default one. and then 58001 and 1972 for in and out for the other port that's available. And then I give it a name of widgets. And I pull it from basically the InterSystems Prod Widgets Directs Global Summit 2017 is where I got this image from myself. I run it. I actually had pre-downloaded this image. So if I go Docker images, I can see that it was already there. I actually downloaded it 4 days ago so that I didn't have to do it over the internet connection here. The size of that, if you can look, this is the application and InterSystems Iris and everything about it is about 2.99 gigs. It's currently running, so I can go and take a look at it if I'd like to. I can go to, say, a browser. Here, browser. And let's go to my Widgets Direct application. Nope, that was the wrong one, sorry. I can log in. And I'm in my application running just like the guy wanted me to have it, with everything involved the same way that we would think of it. I can do everything in here that I'd want to. I can also, if I want to, go into the system management portal for this. I can attach a tally to it. I might as well try to do that. That sounds like a fun thing to do. And in here, I think I have a server already set up for it. I do. Well, that's good news. So I can take a look at it and take a look at my Widgets Direct namespace where everything is installed. I can take a look at all my classes in there. I can take a look at all the REST stuff, the RESTful dispatch class itself. I can pull that in if I want to. I can pull it over and do other stuff with it. Typically, though, I would have already pulled all this from Git and then been able to just update it once I got this in here and make sure that it was correct on there. And then I have the different classes for the different widgets and utilities and everything else. Away we go. I can also get into the terminal if I want to, just because we've opened up all the different ports, right? We've opened up things. Plus, when I'm sitting here at the command line, I can just get in and do what I want to as well. I can also do let's see, Docker logs. I can see that from the logs of Docker, I can see that InterSystems has started. InterSystems Iris has started, and that's about it because it's actually still up and running. Have many people used Docker here? I'm just curious. Containers? Okay, quite a few. Those who aren't, one of the things you'll find out very quickly about Docker is that it is very much a command line interface. There's also some nice GUIs for sort of managing these things. I didn't have time to actually download them before, but when I repeat this session, I will have them. So we'll probably go with that recording, and you'll be able to see some of that as well. The nice thing about it is that the Docker Hub itself has great learning resources. So if I go to just docker.com, there are great documentation and resources and abilities to do a community here. The documentation itself, there's great stuff about getting started with Docker, really understanding what Docker is. There are all sorts of YouTube videos out there that sort of go through the whole, what is a Docker container and why is it important and what does it do type of thing, as a resource for you as you go forward. If I then stop my container, notice that it is taking time, right? Because it is shutting down InterSystems Iris correctly. And that's one of the nice things that ccontainer main does for you. And if I look at my logs again, I can see that, yeah, it actually stopped successfully, and it's actually down right now. Okay? That is a lot of what I was going to do on that. Let me get back to my presentation here. Next thing I want to do is really give the advantage of having one of our customers who uses containers quite a bit to just give a brief overview of how they're using them with our technology and even without our technology in some cases. And then after that, I'll probably open it up for some questions and we'll go from there. So if I could have Ben Cobb from InterSystems, welcome. And that works right there. Yep.
Hi, I am Ben Cobb from InterSystems. I'm the lead site reliability engineer for the Ontario Cloud. InterSystems is a software development company, and we're a leading receivables management services provider. So we provide software for collection agencies, hospitals, government agencies, financial services, that sort of thing. For the last few years, we've been investing in cloud-based software as a solution products, and with those we've been architecting them with a microservices architecture. We base them on AWS as our cloud provider, and they're powered by InterSystems Cache. We've been using containers for probably a couple of years, working with folks at InterSystems to partner and try to containerize Cache and do that, and have been quite successful with it. So all of our development environments, we use Cache now. We don't have developers running instances directly on their personal computers, which is pretty nice because for our system, for some of our new cloud apps, we might have as many as 5 or 10 different Cache instances, all federated together, mirrored, using ECP, that sort of thing. So to set up a dev environment without containers might take hours or a couple of days even. But with our Docker containers, it's essentially a matter of a few minutes. You say Docker run and it runs. And moments later, you have a full-on dev environment that is configured exactly how you want it, looks how you're going to run in production, that sort of thing. So it's pretty nice from that perspective, bringing new customers or new devs into the engineering team. We use an agile development environment, or process. So as priorities change, as important bugs come up, if a dev is in the middle of a big project but needs to switch to some other priority, it's pretty easy just to stop those containers, set up a new dev environment with a new set of containers, and then do the coding as necessary. So it's easy to switch context like that without kind of losing where you are and without burning up all your personal resources there. Our software development life cycle, we span, we do our development in our local dev systems. We use Bitbucket as our code repository. And so when we merge something into the main line in Bitbucket, we have a Jenkins build, which is triggered. The Jenkins build does exactly what he was actually showing there on the screen. The Jenkins build creates the Docker image. And then in our case, it goes ahead and deploys the Docker image as a container onto one of our build servers. The build server then runs all of our automated tests against it, captures the test results, and then destroys the container. And then those results are shared with the team. So before we even get to the QC department, we've already run our full test suite on it, and nobody had to actually physically do that. And we have those results. And so then from our QC department, they have the exact image that they might use to do their testing, whether it's automated testing or manual testing that might need to occur. And then if there's any problems, then it's very easy to work back and forth with dev. You don't have that conflict between your test and dev departments because they're all working from the same platform. You don't have, well, what system are you working on, or what did you change in your environment? Everybody's, in fact, using the same environment. It's also pretty nice from an upgrade perspective. So when we want to take a new release from Cache, InterSystems Cache, or one of our other underlying vendors or whatever, no problem, you update the image, and then everybody gets it. And so, the next time a dev pulls the latest image, or next time we run a QC run, it'll automatically all go in, and you don't have this, managerial nightmare of trying to get everything upgraded. We also see benefits from it in our production environment. For example, it's pretty nice from an HA perspective, or from a capacity and resource perspective, because you can quite easily spin up a new container, or spin down a container as you need to manage your capacity. Or if you have a bug that happens, something crashes, you can just stop that container, spin up a replacement container, and then you take that other container offline or something at a later point and debug what might have happened to it. And so that's all, for us, it's been quite a boon to productivity in terms of the developers being able to quickly and agilely move things around, and then being able to deploy that through the entire development lifecycle without, some of the pitfalls that you typically run into.
I would imagine, Ben, that it probably took a while to get to that level of competency. So I know that we've said it a number of times, but going to something like containers is sort of like going to another platform. So you really do have to understand it pretty well. Could you have a good idea of how long it really took you to get proficient and have that all planned out?
Well, we started with a pretty small sort of prototyping team to do that, and they kind of worked out the kinks and figured out what we needed to do that, and then rolled it out sort of one team at a time to the rest of our development organization. And it is a process. It takes some time, but honestly, once you kind of work out the process of it, bringing new devs on for the rest of the department was really quite a simple thing. It's pretty straightforward. Docker's pretty easy to use. It is a command line interface, so you have to understand the command line interface. But it's pretty straightforward, and then once we've done it the first time, we've got lots of examples, So all of our repositories essentially have a Docker file in them that describes, how that Docker file is built. So you can pull up any repository and use that as an example. If you're building a new one, and then it's easy to run. It's so much easier to run tests or verify or try out things that other development teams have done. Because if you've not been on the team and you're not sure, it's like, okay, how do I get your code? Well, we don't ask that question anymore. You pull the repository and you Docker run, and you have a working system. And so it's pretty nice from that perspective.
Okay. That's pretty much most of what I have to go through. I thought we'd open up for questions. I do have a couple slides about other sessions and things like that, but I'll leave those for the last couple minutes so that maybe we can get some questions in. And Ben, if you want to stay up, they might have questions for you too as well. Is there any questions out there? Oh, thank you. I think there was one to the left.
So I've always thought of containers as a tool for development, but the notion of using it in production is interesting. Have you found that it's an aid to keeping a consistent configuration from one, maybe one customer to the other, so you have everybody basically running the same thing? Have you done anything with consistent production configurations?
So we haven't run cache inside of containers in production, but we do run other systems inside of containers in our production environment. And we do find that makes it so much easier from a deployment perspective, because you're consistent across the board. Everybody's running the same thing. When we do it, it's a cloud-based SaaS solution that we're using. So when we want to do an upgrade, we roll the upgrade. We roll it across all of our containers, and then everybody has it automatically, and they don't even know that they got an upgrade. And then, if you encounter some problem with it, run some smoke tests or whatever, it's super easy to roll back. You just simply deploy the previous version, of that image.
Thank you.
Other questions?
I was wondering what host OS that your developers use to run the containers. Are they using Windows, Macs, Linux?
So we primarily use Linux, Ubuntu. We do have developers that use Windows because they need to develop some other things on Windows, but most of them, if they do that, will run a VM that's running Linux inside of it and then run the Docker stuff inside of that.
What's the guideline around a containerized cache? Because oftentimes projects share the database. So if you containerize it, it's wrapped inside that project. So what do you do, or what's your experience in terms of the cache database itself? It's containerized within the project.
So the cache database is mapped out to a volume on your local hard disk in whatever environment you are. So we have environments that are run on your local dev environment. We have environments that run in AWS, and they're mapped out to a volume there. And so you have that sort of separation between data and your code base. As far as sharing dev environments, we do that to some degree with our AWS environments because they are costly and they run by the minute. But for the most part, it's so easy for everyone to have their own that we don't really worry about sharing dev environments. That's one of the advantages that we have found from this, is that everybody can have exactly what looks like the same environment, but it's actually their own, and they can do anything they want to it. And if they destroy it and mess it up, who cares, because they can just create a new one.
In the production environment, if the project goes live, if it's containerized, then it's locked together in that project. But if your project is one part of the overall, within your organization, the database oftentimes is shared. You don't want to be creating, a separate EMPI. So, do you containerize cache by itself? You don't containerize it, it's outside the container and just the code is containerized?
So the way we've approached that is that we have a sort of a database server that is a cache database server that stores the data, and then our other applications run as cache instances and access that data using ECP, and they might be running a variety of different software. So you might have any number of sort of ECP application servers that are all accessing data that's stored in the database server using ECP.
I think one of the things that we are recommending as far as real data that is changing is that it should be an external volume. And as long as that external volume can be seen by multiple other containers that are up that are mapped the same way, then with ECP or whatever, then you're going to be able to see that data. Does that make sense? Okay. Any other questions? Got one up front?
We mostly use Studio, but we do have some devs that are using Atelier, so some of both.
But you mentioned that most of your developers use Linux.
Yes, that is true. So we have developers that will, like I said, they will run Windows and run a Studio in Windows that is connecting to the VM that's running Linux that has the Docker containers running them. We also have devs that do it the opposite direction. They run Linux on their host, and then they have a Windows VM that's running Studio, or they just use Atelier. We have all varieties.
It's right in the back.
So I love the idea of using an ECP server to mount individual private developer instances to transactional data that's necessary to do the testing and whatnot. I'm just curious, what's your strategy for preventing a developer from blowing up that data, so it impacts everybody else? Do you basically have are those like copies from live that you got backups of so you can just restore it if somebody trashes it, or how do you handle that?
Yeah, we don't give developers access to live production data.
But I mean, is it a copy from live you bring back to dev for the sake of?
So we do one of two things. If it depends on the data. Some of our customers work with sensitive data, and we're not allowed to really share that. If it's a situation that doesn't do that, then yes, we will simply do a copy of the data, bring it back, and that works quite nicely. Otherwise, we've written generation tools to generate data that looks like redacted data from prod, based on analysis.
Cool. Let me take just a minute, since the questions slow down. Think about your questions for a second, and let me go on a little bit. There are other connected sessions that are dealing about containers. A lot of these have passed, of course, but here's a full list. You also have, of course, the presentation on your app, so you can actually look at these again and sort of get to them quicker. There's also, I was showing the Widgets Direct application a little bit. Here's more information about that and where you can get it. And then here's some other sessions that deal with that. Again, some of those have been passed already since we're most of the way through the conference, but you can look them up again in the app, download all the stuff. Afterwards, we'll even have more information on there, other files that you can download about them as well that you can help as also. And please fill out the survey so that we know, what sessions you liked, which ones were helpful, which ones weren't. You can also go to Learning Services. Please visit the Tech Exchange to learn more. And then for the last 3 minutes, we can probably do any more questions if anyone has any. If not, I'll see you at casino night. I'll buy you a beer since. Thank you. Thank you, buddy.